Looking at 7 day 2, we're talking about inverse functions again. You can go ahead and treat number 1 and 2 as warm-up problems. I think that would be beneficial for you. So feel free to pause the video and try them out first, and then hear me go through them. So for number 1, what you would do to start this problem is just switch x and y. So this now becomes x equals y plus 2 squared minus 4. If you want to start the process of solving for the new y, you would add 4. So we have x plus 4 equals y plus 2 squared, right? So we're going to go ahead and take the square root of both sides. But again, whenever you take the square root of something, you have a plus or minus. Oh, that would be an x plus 4, sorry. And that equals y plus 2 because it cancels the square. So the only thing left to do is subtract 2 over, right? So that would end up being my final answer, -2 plus or minus the square root of x plus 4. Now you should throw the -2 out in front because it makes more sense with the whole plus or minus thing. But if you had it at the end, that's fine as long as it was not underneath the square root. For number 2, again, we're going to switch x and y. And again, remember, f of x is just a fancy y, so that's why it just turned into x. And we're going to solve for y by adding 4. So we have x plus 4 equals -2/7 y. And this next part you can do in 2 parts or 1. You can multiply everything by 7 and then divide by -2, or you can just multiply by 7 over -2 right now. Okay, either way you end up with, and I'm going to write it over here, 7 over -2, x plus 4 equals y. Now I'm okay if you keep it that way. That's not a big deal. Otherwise, you could distribute it if you wanted. -7 halves x, and this ends up turning into a -14. I do prefer it being distributed out, but either answer is acceptable. So now we're going to get into the whole why we did this, okay? Verifying two functions are inverses of each other. In order to verify that things are two functions are inverses of each other, you need to do Fogg and Goff. And when you do Fogg and Goff, you're going to get y equals x, okay? Or you're just going to get x as a remainder. Now, the reason is this is your line that they reflect over. So if you think about it from the very start, right? We graphed 1, and then I said, "Hey, look, they're going to graph, or they're going to reflect over this line." Well, that line is what this is creating. Okay, Fogg and Goff create that line. Okay, so f of g of x and g of f of x have to equal x. So if you have two functions like we see in number 3, and they say to verify if they are inverses or prove that they aren't, you would have to do Fogg and Goff. Either way, you need to do both just to prove it. Okay, so this is really saying f of g of x, which means g of x is replacing x in f. So this first time we're going to take g of x and plug it in here. So this becomes 3 times our new x, which is the whole function of g of x, plus 9. So we're going to go ahead and distribute the 3, and we end up getting x minus 9 and then plus 9, which obviously go away, and we're left with x. So this is perfect. We're supposed to get x. On our next one, this is g of f of x. So that means we're taking f of x and plugging it in. So we're going the other route. F of x goes in for x. So this time, we're going to have positive 1/3 times our new x, which is 3x plus 9, and then minus 3. When we do that, and we distribute the 1/3, we get x, and then plus 3, and then minus 3, which cancel, and you're left with x. So because both of these are left with x, yes, they are inverses. If one or both of these do not end with x as your final answer, then these are not inverses. All right, so we are going to do this 2 more times, and our last one, we're just going to find the inverse, so work with that again. Okay, so feel free to pause this and try these two before you keep going. Okay, so the first one we're going to find is f of g of x. So we're going to take g of x and plug it in for f. So we get 2, and then the square root of x plus 1 over 2 squared minus 1. Okay, so obviously square roots and squareds cancel, so we're left with 2 and then times x plus 1 over 2 minus 1. Okay, now at this point, the 2's cancel and you're left with x plus 1 minus 1, which again, 1 and minus 1 cancel and you're left with just x. So the first one worked out, but sometimes the second one doesn't. And if you already worked ahead, this one ends up not working really. So we're taking f of x in this one, and we're plugging it into g of x. So this plugs in here. So we now have the square root of our new x plus 1 over 2. And you probably looked at this like, what, right? And that's exactly what I would say. Okay, we have the square root of 2x squared, and then the minus 1 and the plus 1 would go away over 2. Okay, so yes, it's like, okay, wait, is this working or is this not working? Well, if we keep going, right, x or 2 over 2 is gone, and you're really just with the square root of x squared. Well, what happens when you have a squared and a square root? Well, they cancel, and so you're left with just x. So actually, we have x and x, which means they are inverses. From here, we can take a look at number 5. So this one's similar because we have the squareds. So let's take a look. For f of g of x, that means I am taking g of x and plugging it in for f of x. Now this is where you could have possibly gotten tricked and said yes. Remember, whenever we take a binomial and square it, we need to write it twice and FOIL. So in this case, when we FOIL, we'd get x squared plus 3x plus 3x plus 9 minus 9. So obviously, if we keep going, we get x squared plus 6x, and then the 9's cancel. Because we are not left with x, no, they're not inverses. Now, if you just did squaring both of them, you might have been tricked here, but it still would have ended up as a no, actually. Okay, but let's go ahead and just find g of x just for fun, or g of f of x, I should say. So this is where we take f of x and plug it in for g. So this would have left us with x squared minus 9 and then plus 3, which becomes x squared minus 6, which is obviously not just x. So no, they are not inverses. For number 6, we're going to go ahead and just have one more practice of finding inverses. So remember, when we're finding an inverse, we don't need to do Fogg and Goff. I mean, obviously for this one, there aren't even 2 options for you to find Fogg and Goff, right? So we're going to just do our process of replacing f of x with y. And then we're going to go ahead and switch x and y. So we have x equals 2/5 y minus 1/5. So at this point, you have some options here. Most of you probably are just going to go the route of, let's go ahead and add 1/5 over. Okay, and that's totally fine. You have x plus 1/5 equals 2/5 y. Now again, you can do this next part in two ways. I'm going to go ahead and get rid of it at the same time, whereas you probably might have wanted to do it in two steps. Now remember, I do want to distribute these in, so we can rewrite this as 5/2 x plus, and then this becomes 5 times 1, which is 5, over 2 times 5, which is 10. And hopefully we notice that that can reduce to 1/2. So our final answer would be y equals 5/2 x plus 1/2. But remember, this is going to be f inverse of x. So 5/2 x plus 1/2. Now, what could have happened back in this red step, okay, if you were here, and I'm going to write it up here, you could notice that you could get rid of the fraction by multiplying everything by 5 to start. So you now have 5x equals 2y minus 1. Then you would add 1, and you get 5x plus 1 equals 2y. And then all you have to do is divide everything by 2, and you're back here, 5/2 x plus 1/2. Okay, so either route would have been totally acceptable.